today I will present some DevOps-ish soft talk, so don't be afraid. I hope you are still hungry, because I prepared some meat for you. And actually, don't be prepared to fail. Don't be afraid to fail. Be prepared for it, sorry. But who am I to talk about it? I have experience in mitigation incidents in production because I was a member of Jira frontend platform team in Sydney, responsible for keeping Jira frontend up and running. Moreover, currently, I am an on-call engineer for Jira server-side rendering service. So, continuous integration, continuous deployments, hotfix processes, rollback, rollforward. Those are things you should know before you need them. But Jira, actually, what is Jira? I will tell you about Jira frontend process delivery. So Jira is a very big product. Jira is just like Dancing Queen, young and sweet, only 17 years old product, uses by millions of users every day. And Jira lives in a separate repository. And I'm talking only about the front-end part of it. It was created 2 years ago, and right now it contains more than 1.3 million lines of code. And we are talking only about the newest part of the code. There is also legacy front-end, backend / monolith, and services working around. So front-end is being developed by more than 250 devs around the clock, all over the world, in different time zones every day. If it's still hard to imagine the scale, how many mistakes have you made during 1 year? Like 10, 20? So there are 251 working days in Poland in 2019. Imagine making just one mistake per year and multiply it by 250 devs. And today I will tell you a story of such mistake. It's going to be a brief story of a commit getting into production and back, because a pull request is only the beginning. So question to you. Who is testing on a production? Please raise your hand. For the records, I can see at least 2 hands. So you're not going to be happy because I'm not going to talk about testing in production. Sorry, not really. Anyways, let's get straight to the story. Here comes the distributed version control system for tracking changes in source code, Git, and the master branch. Whenever a developer in Atlassian starts working on a new feature, they use a well-defined process. First phase is kickoff. It's just a brief meeting with your teammate to discuss the problem, propose a solution, and define the criteria of acceptance. For example, what should be tested. Next step is just a regular boring work, means coding and testing and stuff on your local machine. This example developer is smart. He splits his work into commits. Every time commit is about to be pushed to remote repository, pre-commit hooked will be called. What does it mean? Only new or modified files are tested on your local machine. I mean tested by slint, unit tests, type checking, and everything. And if everything is fine, you can push your work to the remote feature branch, and this action triggers another build. So every time the commit hits your remote branch, Bamboo triggers build. In our case, it's Bamboo because it's Atlassian product, but it could be as well Jenkins, Travis, Circle CI, or any other automation CI/CD tool that you prefer. And by saying a build, I mean not only Webpack build. It's a multi-stage job. Tests, unit tests, integration tests, end-to-end tests are run, types are checked, security scan is performed, repo structure is checked. But what is it, repo structure checked? We've created automation tool able to scan whole repository file structure. For example, you cannot create file foo.js, or you cannot create view without storybooks with examples of these views, because we are using as well visual regression tests. Also, bundle size are analyzed, and just to spot the potential regression, and so on and so on. But those checks are not verifying every file in your repository. Branch build is testing only files that are modified or affected by your change. For example, if component A has been modified, and it is used by component B, but component B files were not modified, still both component A and component B will be tested. However, if there is another component C, this one won't be tested at all, because it doesn't make sense. So we are saving time and money, and trees. Saving trees is a good idea. Please do it. So when the feature is ready, it's time to merge it into the master branch. Every feature or fix has to be merged into the master branch. It can be done at any time in order to be deployed. It is called continuous integration. So here in this example, a pull request has to be made. Jira has a friendly bot called Gollum. It keeps his precious repository green and healthy. So this bot will assign reviewers to your pull request. How? Every file in Jira repository has an owner, and I mean a team. So if you are modifying code you don't own, you are not allowed to merge changes without the owner's approval. Gollum is also able to send Slack notifications. And once you get your approvals and branch is ready to be merged into master, it's time to do a QA demo. Every developer has to do a quality assistance demo of their feature before clicking merge button. While this example developer was working on his new feature, other developers merged their changes. It means that your branch might be outdated. There might be some conflicts and so on. And that's why once change is merged into master branch, whole repository has to be tested again. So again, merging triggers a build, and every merge commit triggers a build. And by saying a build, it's again not only Webpack build, but also test, unit, integration, end-to-end, VRs, everything. Also type checking, security scan, repository structure scan, code style check, bundle size analysis, building storybooks, SSR build, and so on and so on. This time, every possible test is performed and every existing file is checked. So once it's done, and if everything goes fine, it's time to deploy. But what is deployment? It's just, like saying simply, it's just sending build artifacts, created JavaScript bundles, HTML files, and static assets to the cloud provider storage, so this can be used in your application. Almost every merge commit can trigger deployment. Almost, because if build isn't successful, it won't be deployed. And if merge was made during build progress, the changes will be joined into a single version. So almost every build will be deployed. And where exactly it will be deployed? Jira frontend has 16 shards grouped into 4 environments. First environment, it's called staging. It is used by developers to test their changes, so it's just a typical test environment. Second, at the same time, the new version will be deployed to the second environment called dog fooding. So what does dog fooding mean? It's just eating your own dog food, testing your own app by using it on a daily basis. So Atlassian, surprise, surprise, uses Jira internally. I mean, not only devs, but also PMs, designers, security, admins, accounting, legal, and HR staff. Everyone, every day, is like 5,000 people at this very moment. We have a separate environment for internal usage. Every change you made will be deployed to the dog fooding immediately. Why? To be able to spot bug as soon as possible, before version will be released to the customers. So we, the Atlassians, are performing manual checks before releasing on ourselves. But there are also so-called synthetic checks. These are automated tests for Jira functionality, like creating issue, viewing backlog, viewing sprint, creating projects, and so on and so on. So synthetic checks are performed every 2 minutes, and their results are regularly monitored. And we are using also anomaly detection to check if everything's just right. Right, so what is next step? Next step is so-called soaking. It's just getting production maturity. as hundreds of synthetic checks are performed, plus Jira is used, tested internally, as we are soaking every version for an hour in dogfooding environment before it's mature enough to be deployed further. Once soaking in dogfooding is done, a version can be deployed to another environment called production canary. It's just a very small percentage of users in same time zones as current working shift. Deployments to production are performed every day, every working hour from 9 a.m. to 5 p.m. during Sydney time, even on Friday. We are the brave ones. Not really, I was joking. However, same as for dogfooding, version has to be soaked before it is mature enough. This time version is soaking for 2 hours. It means if your changes were merged at 9 a.m., let's say the build takes 30 minutes, so at 9:30, version will be deployed to the staging and dogfooding, and after an hour of soaking, so it's 10:30, it will be deployed to production canary, where it has to be soaked for another 2 hours. Once this process is done, so once soaking production canary is done, version can be safely deployed to the rest of the customers. So it takes about 3.5 hours of a commit to be deployed to the whole production. Everything is fine, right? Well, not always. Sometimes bug slips into production despite all the test stages where it should be detected. So sometimes it happened. What to do? First of all, it will happen to you as well, sooner or later. So you have to be prepared for it. But what is the process? Just keep calm and decide on the severity of an incident. But what does it mean? When monitoring or employee catches an error during soaking or a customer raises an issue, incident has to be made and impact should be specified. It should be categorized. You could use, for example, 4-grade scale to measure it. So, SEV 0 means crisis. It basically means that we are out of the business and, for example, it's data loss, security issues, and total outage. Such an incident has to be fixed immediately. There are dedicated teams to keep Jira working. SRE means Site Reliability Engineering, and JFP stands for Jira Frontend Platform. And those step into actions. Jira SREs are on-call engineers. It means that they can be paged at any time, and they have 15 minutes to acknowledge and for the first response to the incident. SEV 0 means all hands on deck. So actually in SEV 0, every engineer in Jira Cloud can be potentially paged. SEV 1 means major functionality is not working. For example, in Jira, it's just like creating issue or using navigation. SEV 2 is minor functionality is not working. For example, archiving version, editing components, and so on. And there is also the last one, SEV 3. It's basically Internet Explorer and CSS. Of course, I'm joking, but those are bugs in category SEV 3 must be fixed during working hours. Every other incident must be fixed as soon as possible. So when we know what the severity is, we should let other people know about the situation. So communicate early. Once incident has been made, communication channels should be established. Separate Slack channel, internal comms, and so on. First minutes are crucial. Sometimes some developers might be aware, for example, of feature flags. I will tell about it later. And they could mitigate this incident within a minute. So make sure everyone is on the same page. Communicate often. Try to be as responsive as possible. Probably you won't be the only engineer working on a fix. So say what are you doing right now so work won't be repeated. Try to communicate precisely. Be specific. It's always better to say that I am preparing a rollback. Instead will be mitigated in 30 minutes instead of I will fix it, period. What you gonna do? Please be precisely. And the last thing is communicate consistently. Use every possible channel of communication. For example, Slack, emails, phones, and so on. If product is developed in different time zones, all the developers should stick to one. And remember that communication is not only internal. Customers must be informed what is going on, because they are trying to use your product. In Atlassian, every incident with severity 2 and above must be managed by a trained incident manager. They are responsible for coordinating process and communication with customers via status page. And remember that status page should be a separate service, because when your application is down, status page will be down as well, so it doesn't work. Next step is to prepare a fix. Fixing a product sometimes might be risky. For example, doing a rollback to very old version, or doing a roll forward as we are doing continuous deployment, so there's going to be like 20 versions between your and the fixed one. So try to choose the safest possible way. Also, always try to choose the easiest and the fastest fix. Rush is your enemy. It's really easy to make a mistake in hurry. Don't try to over-engineer or show off. Last thing you want to do is introducing another bug. Keep in mind that customers are unable to use your application or its certain feature at this very moment. After the fix is made, it's time for drawing conclusions. So first, create an incident review. It's a simple document containing timeline of the incident, descriptions of what happened, how many customers were affected, and information why it happened. Like, no worries, no one is blaming devs for making mistakes. It happens. But learn and spread the knowledge in order to prevent similar class of incidents from occurring again. And last thing is take an action. How could you prevent this from happening? By adding additional tests, modifying the whole process. Be the change you seek and create a priority action to make sure it won't happen again. But technically, how to fix broken application? Like, there are many ways, and let's focus on 4 most popular ones. First is using feature flag. Second is doing a rollback. We can also do a roll forward or do a hotfix. Right, but what is this feature flag? So it's just a simple concept. It's like light switch, for example. It has to be implemented in your code. If feature flag is turned off, app is using old code. If feature flag is turned on, app is using new code. Feature flag must be separate from your app, because if your app is down, feature flag service will be down as well, so you won't be able to modify feature flag values, and sometimes those can just keep your app running, right? So, however, if feature flag server is down and your app is running, you can still use default values provided in your code. So you can write your own service or use existing solution. In Atlassian, every code change must be hidden behind a feature flag, even if it's just a CSS change for SVG in ESX, every single one of them. Moreover, you cannot just turn on your feature flag without noticing SRE team. Every day there is a meeting called Chopper, and during Chopper, you have to show SRE that app works when feature flag is turned on and where it's turned off. Moreover, you have to present monitoring of the usage of your feature. So despite the fact that we are using continuous deployment, we are deciding when this feature can be turned on. It sounds complicated, but it helps us a lot. It's easy to find a breaking change and just turn it off. Feature flags also allows us to decide when to turn the feature flag on and to whom roll it out. For example, we can use percentage rollout or just use 5% of user in particular time zone and so on and so on. Full control. But to use feature flag, first of all, it has to be implemented. And second thing, if you don't know what is the root cause of the incident, you still have to mitigate this as fast as possible. So sometimes it's just not even easy to use it. For example, bumping dependencies. Of course, you could, for example, create a separate branch to rolling to production from the separate branch when the feature flag is turned on, but it's like a lot of pain in the ass. So other options, rollback. Rollback can be done if you are keeping previous version of your code. And then you can just switch to the working one if current production is broken and you don't know why. Sounds easy, but sometimes it's a little bit complicated. Continuous deployments means every version might be deployed, and sometimes it's hard to find working one if you don't know what is the root cause of an incident, right? So how to check which version is working? You could add an easy way to force using particular version and, for example, use bisection to determine which version is safe for redeployment. One more thing, mark broken versions and make sure this won't be redeployed to production. So imagine the situation that we've got the broken version and fixed version, we are doing rollback, and then it's gonna be automatically redeployed because it's continuous deployment, right? So you have to create a blocking mechanism. If there is a blocker and there is no working version newer than the current one, don't proceed with deployment. But if you know what is the root cause of the incident, why don't you just fix the bug, right? You can do it, and that is called rollforward. Fix the issue, deploy new version to staging and dogfooding, confirm fix, and deploy new version directly to the production. So again, there is a trade-off. New version is not going to be soaked in production canary and dogfooding, and there might be more changes than just yours, right? Because other developers could merge their changes. Sometimes rollforward is not a safe option, so... Oh, there was also animation. Yeah, so this one is broken, but there is a fixed one, and there is soaking. Sorry. So what is other option? It is called hotfix. You could keep your code used in the current production build in a separate branch, then production or green master, and apply the fix to this branch instead of the master branch. It's just creating a new branch of current production code, fixing stuff or reverting breaking commits, merging it, and then redeploying current version with fix applied. I know it's all complicated and you are probably not DevOps, so let's just briefly catch up with the most important things. First of all, always use safest and fastest fix. Don't show off, don't try to fix stuff in rush. The best way is, in most cases, just reverting breaking changes. App is already broken, it must be fixed as soon as possible. Use clear way of assessing severity. First step is crucial. Not every incident must be mitigated right now. Sometimes bugs might be caught in dogfooding, and it won't hit the production at all if you know how to stop it. When in doubt, go with higher severity. Higher severity means just more people involved in incident mitigation and faster fix. So stay safe. Always keep your master branch green. Sometimes reverting commit is the only way. So you don't want to fix failing tests or typing during incident because someone broke the master and you just cannot merge your changes. Use feature flags. Feature flags are cool. They help a lot, believe me. It's a topic for a full-time presentation. Communication is the key. Internal and external. Every developer must be able to precisely communicate with other devs. It's crucial to coordinate the whole process. Don't F-word the customers. By the end of the day, they are paying your bills. You might or might not be DevOps, but please, 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 don't be DevOps. And the last one, don't be afraid to fail. Be prepared for it. Last and probably the most important thing, it happens sooner or later. If you are using cloud, it's going to happen. Make sure you are ready for it. There is a repository called No Code by Kelsey Hightower on GitHub. Its description says, the best way to write secure and reliable application, write nothing, deploy nowhere. It contains literally 0 lines of code. And you know what? It has almost 2,500 issues raised. So that's all, folks. Thanks again. If you have any questions, please, just one question, actually. I heard one question, so I'd like to answer it. Why Jira is slow? It is not slow. So yeah, if you have any questions, please reach me out on Twitter, Facebook, LinkedIn, GitHub, or anywhere you like. For example, somewhere where the beer is. Thanks. Cheers.